decay branches. What I mean by this point, in general, you can find in the nature one element, one unstable element uh, can decay through many decays. We can say many decay branches. For example, alpha and beta, or beta plus and beta minus. In the same time, this element decays by alpha with alpha emission and beta emission. So here we have lambda alpha and lambda beta. And we can say the total decay rate equal to the summation of alpha, lambda alpha, and lambda beta. For example, here we have Cu 64 decays to Ni 64 with beta plus. The same element decays to Zn by beta minus. So here we have 2 lambda and we have 2 probability to decay to alpha and to beta. Okay. Now we have to find the relative probability for each branch decay. We can say branching ratio. Br alpha and Br beta equals to lambda alpha divided by lambda. Lambda is the total decay rate equals to lambda alpha plus lambda beta. And also we can calculate the relative probability of beta, which is equal to lambda beta divided by lambda alpha plus lambda beta. Okay. What about the lifetime and the partial lifetimes of this kind of decay when we have decay branches, 2 decays, alpha, beta, beta plus, beta minus, and so on. So we have to calculate here the total lambda. You know the total lambda equals to lambda alpha plus lambda beta. This is the total decay rate. And we have lambda alpha is the partial decay rate of alpha decay. And lambda beta is a partial beta decay of beta decay. Okay, or beta emission, beta process. We can say beta branch. Now, also we have to calculate the total lifetime. The total lifetime. In order to calculate, to analyze the expression, you know this element, some part decays by alpha and the second one by beta. The total delta n divided by delta t equals to minus lambda n. Lambda is a total decay rate. N is a total unstable element. Okay, total unstable element of all the nuclei of the parent element. You know lambda equals to lambda alpha plus lambda beta, and you can substitute and simplify the expression. We get here n lambda equals to n0 exponential minus lambda t. And you know the lifetime of the parent equals tau, okay, equals to 1 divided by lambda. Okay, here be careful. You can calculate the partial lifetime for each one, tau alpha and tau beta. And if you want to calculate the lifetime of the parent, you have to write like this. Okay, this is the total expression. You know here tau equals to 1 divided by lambda, and lambda is a total 1. To calculate the lifetime of the parent, you have to take this one and you can solve it. Let me explain one point, the last point. If we have a summation like this of the total rate, the dominated one is who has the larger gamma lambda. Okay, so the total rate is dominated by the larger lambda. If we have more uh, probability of alpha decay, so in this case lambda alpha dominates, and uh, the same for beta. And also for the lifetime of the parent is dominated by the shorter partial lifetime. Okay, so uh, because if tau alpha is small, in this case, this one is large. Okay, so we have the opposite term. We find the lifetime by 1 over tau. Anyway, here I give you a table where I resume not all the expressions and equations, but the most. Each time you get a new one, we can add it in this table. Like this, we can have a global view of all the expressions calculated before.